All right, let's go ahead and get started. Thanks everybody for joining today's webinar. My name is Joe Raldies. I'm the VP of Marketing at Cast. We've got an exciting webinar today. You are not here to listen to me, so let's skip to the next slide and we'll introduce today's speakers. Awesome. Bertram, do you mind introducing yourself?
Sure. So I'm Bertram. I'm a CloudOps engineer at Mercedes-Benz IO. And Mercedes-Benz IO is one of the companies taking care of the digital channels for sales, e-commerce, after sales in the Mercedes-Benz world. And yeah, we adopted Cast a couple of months or even like 1 or 2 years ago. And yeah, this talk is about sharing that user story. I'm not sure if I need to talk anything more. If there are questions to my person, we can handle them later.
Awesome. Thank you. Skander?
Thank you, Joe. I'm Skander Belli, Technical Account Manager, managing EMEA, and I was partnering with Bertram to make sure that Mercedes-Benz Kubernetes infrastructure is optimal with Castilla.
Awesome. Thank you both. So the reason for today's webinar is at KubeCon in Europe a couple of weeks ago, Bertram and Skander both did a presentation on what Mercedes-Benz is doing to overcome node scaling challenges and to optimize their nodes. We had standing room only, and a lot of people came up afterwards and said, hey, would love to go a little bit deeper. So today we're going to be kind of expanding upon that conversation and sharing what Mercedes-Benz is doing. If you go to the next slide, Skander. Awesome. So we're going to talk about node scaling challenges, cluster bin packing, workload rightsizing, managing spot instances. And then we've got a Q&A at the end, which is a little bit misleading. We want to keep this conversational. If anybody has questions as we're going through the presentation, please feel free to add them to the chat and we'll ask those questions in real time. So please don't wait until the end. If you've got a question, let us know. I'll jump in and read the question. And with that, let's kick things off. Over to you, Skander and Bertram.
Good, nice. So let's start by explaining the pain point of Mercedes-Benz IoT and why Castilla helped to solve this pain point. So in this slide, we wanted to show you the main pain point for Bertram team and DevOps team at Mercedes-Benz. So Bertram, the stage is yours. Feel free to elaborate on every pain point.
Yeah, thank you, Skander. So maybe first of all, before like going through the single steps, we at Mercedes-Benz IO are part of, or like I'm part of the platform team. So and we have the approach in the company like being responsible as a platform for the infrastructure, but the application team's taking care of the operations of the application. So we are kind of out of the picture when it comes to like operations development of the use cases they have or like the business logic they implement. And due to their operation, they are also like have a lot of like, let's say, freedom in our platform, and that also arises like a lot of challenges having like this kind of platform and product team approach. I just wanted to tell that again because we need to have that in mind, because everything what we do is like doing at scale and about enabling also other teams to apply like those new methodologies, let's say, when it comes to scaling, auto-scaling of nodes, or also workload scaling, which we probably talk a lot about today. So that's where did we come from. So our setup, we are running on AWS. We were formerly using just a cluster autoscaler with native EKS node groups. So we had like fixed nodes, instance types, and now like looking at the slide on the right side, we see if like you have a given fixed node size, not every use case might fit into that size. So if teams needs to have like bigger node sizes or want to have smaller ones for different reasons, or for their use case just another type, that would need manual interaction from the platform side. Like we would have a ticket, support effort would be there, so there's no like dynamic setup there, and that was like one of our pain points. Then also the other thing is with like having static node sizes, every node is the same size, and this can quickly lead to fragmentation in the cluster. So like maybe like a node was way too big and ending up with just 1 or 2 pods running. So there was no like active bin packing, let's say, in place. And that, led to a lot of resource waste, let's say. Then, as I already mentioned, that all of that, we are doing that at scale. So we have in our environment like 120 or even more clusters. I'm not sure this is a dynamic number because we are often onboarding, doing on and offboardings of teams quite frequent. And also the maintenance of the actually instance type is so it's a manual effort. So it's not like logic picking like the best node type or like the latest one or the cheapest one. It's like this is like a defined instance type which we would need to maintain on our own to update this one as well. And also what we struggled not too much in the past, but also like we're aware that like teams didn't really right size their workload. So we had questions, say what is the right CPU or memory amount? What should I put on my workload? And helping teams with that, so also have benefits in more efficient usage of the resources of the nodes, was a focus point, let's say, in going down the road adapting a solution like Cast. I think.
Thank you, Bertram. Thank you. Yeah, I'm going to just give you more details about this complexity of solving the problem. So Bertram was mentioning that there is a pain point at node level and also another challenge and complexity to right size workload at application level. We'll see in the next slide why CastCI was the best product to manage both node and workload, because we offer a holistic optimization approach. We can help you right size workload, but also do the right smart instance selection, beam pack workload to eliminate wasted resource, ensure performance, and cut costs. So this is one of the complexity of Mercedes-Benz environment is the scalability also. Think about an automation to manage the scale of 120 plus cluster. No guessing, no manual patching. It's an automation that will solve this problem. Good, thank you. We can, I think, move to the next slide. Or if you have any question, feel free to post it on the chat section.
No questions so far. Let's move on.
Nice, good. Okay, so Bertram, feel free to explain how the beam packing works and what are the benefits of enabling using CastCI for the instance selection part.
Okay. So as described in the challenging part, like fragmentation of a cluster was like a big issue that like a lot of nodes were there because like a couple of like pods were basically still there. And there's like one bin packing advantage in using Cast is they have like a procedure, and I think it's also something unique called a rebalance. So what a rebalance is doing is based on the current like resource requests in your cluster, based on all the workload which is running there, calculating the most cost efficient and resource efficient, therefore also resource efficient setup of your cluster. So what it does is spinning up nodes, taking into consideration all the scheduling constraints you have. So for example, having topology spread constraints or affinity or anti-affinity rules, like based or like taking those configuration into consideration. The most optimized cluster setup is spawn up, and the former cluster setup is like spinning down. So everything is getting like moved to a new node, which also helps to maintain some certain or like a certain level of node hygiene, so you don't have nodes running too long in your cluster, maybe also fragmenting on the memory level or whatsoever. So this is like the procedure of the rebalance. And the other side, what CastAI provides, and I think there are also like a lot of projects in the community out there, is like doing the same in runtime. So for example, the autoscaling mechanism just picks, like for example, if the new workload is getting scheduled, there's not enough room on the cluster, there's a node is getting spinned up just to accommodate this kind of workload with like its memory, resource request, and so on. So also in runtime, your cluster dynamically scales on just what is needed, and you don't have the fixed instance types. As we had for example with EKS native node groups before. You can say it's like kind of a carpenter like scheduling or like scaling experience. Probably Skander can jump in and tell you a bit more what are the benefits here.
Exactly.
Yeah,
good question. So I would like to explain maybe in details how the beam packing works. So we run different simulation. We use different AI algorithm to find the most optimal scenario for beam packing. And as Bertram was explaining, we take into account this application requirements, the node affinity, the node selector, the topology spread constraint. We'll feed all this criteria into a decision-making system, and we will run different simulation. And thanks to the AI capability, we can end up with the most optimal setup. Because again, we want to offload the complexity of managing instance selection and managing Kubernetes to an automation. So here, you will not decide if C5 is the right one or M5. It could be maybe another R5, or it could be big machines, small machines. So we run different iteration of beam packing algorithm, and we end up with the best scenario in terms of pod placement and cost efficiency. As you can see here, we move from 142 CPU to 80 CPU, because the beam packing by design will help you to eliminate wasted resource. Because we think that DevOps team, they do a lot of over provisioning by design, because they do the guessing. When you guess about the instance type, when you guess about the workload request, you end up with 40, 60, 70% of wasted resource. So this is the benefits of using CastAI rebalance. I mean, how we can move to how we can move to the most optimal configuration seamlessly. How it works under the hood. We'll create new nodes. We'll respect the PDP. There is a timeout of drain. Then we move the new workload to the new optimal configuration. We cordon, we drain, then we delete the old ones. So it's like a seamless migration to the most optimal configuration. This exactly. It can be manually executed, but also it can be automatically scheduled. So, for example, you can do a nightly or a weekly or even an hourly. There is something very interesting here in this slide. We see that the cluster is using Spot, but here we are moving from $3,000 per month to 400 something per month. So even with Spot, we can help you find a cheaper spot, because Spot is like stock market. The price goes ups and downs. Every cloud provider is changing the spot price frequently. So we maintain an optimal cost even for your spot instance. This is very interesting.
Skander, we've got two questions really quick.
Yes.
One is, what are the threshold values?
Can you what's exactly the meaning of threshold?
Threshold, the definition, like what's the trigger? Like, is there a trigger in the values? Sampath, if you could expand upon that question.
Good question.
What we'll do is let's come back to it, Skander.
Yeah. So, for example, if you want to do when you
Skander, I think you're having some Wi-Fi issues. You froze on our end. Can you pause your video? Skander, you have frozen for us. Can you do us a favor and pause your video? Sorry, everybody. Skander is at an event right now, so he's on the event Wi-Fi, which is probably causing the issue. Bertram, maybe this is a question you can answer. Does the config change based on CastAI analysis for node scaling, done or triggered automatically by CastTool or manually?
No, this is like an on-demand thing, so you can do it manually. trigger a rebalance, or you can have a defined schedule. So there's no like automatic trigger to just like do this kind of procedure, or like the rebalance. What you can do is triggering on demand, or having a schedule, doing it, I don't know, every hour, every day, every week, every month, once a month, whatsoever. But yeah, maybe the other question can elaborate a little bit on what's the threshold.
Yeah, so Sampath, thanks for following up. The follow-up that he had was, on what basis do you do scaling?
I mean, we track the real demand of workload. So when there is a new workload coming and pending, we create nodes. Then we delete when this workload disappears. So it's a real-time, dynamic, automatic scaling. We scale up and down efficiently based on the demand.
All right.
Any other question?
Yeah, Sampath, if you have an extension to that question or we didn't answer it all the way, please let us know and follow up, and we'll make sure we get it answered for you. Are there any other questions on this slide? Otherwise, we can move on.
If
Good.
just one before maybe going to the next slide, as we like mainly now talk to the about the rebalance, but get back to the bin packing. Sorry, Skander.
Yes.
So as we talk mainly about the rebalance, I also already mentioned basically the change of the autoscaling component from the cluster autoscaler, like in our case, to like the one of Cast AI, doing all the like scaling decisions in runtime. Similar to, I would compare to Carpenter, with like additional functionalities. And then there's another a component out of the box which is provided, which is doing actively bin packing in runtime. It's called the evictor. It's from a functionality point of view similar as maybe most of you know the descheduler in the Kubernetes ecosystem. So what it does, it actively shifts workload from underutilized nodes to more utilized nodes. So those nodes can be shut down, and you save the money and also the resources. And this is also part of the, let's say, active bin packing in runtime, what comes as an inbuilt component when adopting that solution. We can also maybe go back if there are questions to that later. I'm not sure if you want to add something, Skander, and also if maybe there are questions, or if we have time in the end, maybe Skander can even
we can dig deeper into it. Yeah. But just I'd like to mention something very interesting, that we have this rebalance mechanism, which is in kind of swapping nodes, moving to most optimal nodes, but also we have something called evictor, which is one of our core components. This evictor is like an agent running in your Kubernetes that's going to scan all your workloads 24/7 and identify if we can bean pack and compact your workload, your cluster into fewer nodes. So we'll move your workload between nodes and delete the unused capacity. So it's a kind of smart, dynamic, automatic bean packing. But you can control that. It's not aggressive, guy. So you can say that, don't touch this workload, put a label on it. Don't touch this node. I don't want to get my jobs interrupted. So it's not a black box. You can fine tune the behavior of autoscaler based on your policy and based on which kind of workload you can tolerate to restart, or you can put. Any other question, guys, before moving to the next section? Because next section is going to be interesting also. We'll explain how the workload autoscaler works.
Yep, we have a question from Nagesh. For spot instances, how things are jumping around my screen. For spot instances, how will eviction be handled? I'm interested in fleet having 500 to 1,000 nodes. Most CSPs change spot price once in a month, so variability in price is not much. Also, how will it be handled? Extra discounts due to exclusive contracts and scaling decisions.
Ooh. That's a very good question, by the way. I was expecting this question. So the AI in Cast AI is our ability to do what we call spot interruption prediction. So we have different machine learning algorithm. We can scan all the cloud regions and we can detect 20 minutes before the interruption. So 20 minutes is enough to provision new spot instance, move the workload, then handle the interruption seamlessly. If there is no spot there is a built-in fallback mechanism at CastAI to use an on-demand until the spot becomes available. So we manage spots seamlessly, and we make sure that every stateless workload that is running on spot has enough capacity to be deployed. And if there is no spot, we do the fallback. So it's automatically managed. You will offload the complexity of managing spot. And I want to take the second question. If you have commit-user RI, saving plans, cards commit-user discount, we can upload that to the CastAI console, and our autoscaler is aware of your discounts and of your RI. So we'll provision the most optimal node for you. So you can tell CastAI to please use this discounted instance type.
Awesome. Great. One follow-up question from Nagesh. Bin packing menus are higher on SKUs like 3248, and if spot, higher chances of eviction. So how is resiliency taken care of?
That's a good question. So before you move to spot, maybe Bertram, we can take this one, how we build together the best practice of PDP, topology spread constraint, multi-replica. I think Bertram going to explain exactly how it works.
Yeah, I mean, we can go a little bit in that direction. Maybe first of all, we probably don't feel that pain too much because we don't have that big of a cluster, as you mentioned. Also, like having a fleet like 500,000 nodes or like super or like bigger nodes. So from our use case point of view, we don't feel that pain that much. We rather have like small clusters per teams. And then they are in charge of their use case and their application on that smaller clusters, let's say. But probably the challenge is a little bit the same as Skander mentioned, to make sure to rely on best practices for resiliency. So there are like inbuilt Kubernetes mechanisms like affinity and anti-affinity rules to spread your workload across fewer nodes, or like more nodes, not fewer, sorry. More nodes, making sure you have pod disruption budgets configured for all your workloads, because those are making sure that there's always pods still running once like there's a node rotation or like a new node spinning up, or like also a spot interruption. So those basically are the two main resiliency strategies I would see here. To load on your application's configuration, let's say. What we also heavily make use in our environment is topology spread constraints, so to run high available throughout all those. And we kind of shift this kind of resiliency configuration or best practices more on the workload side, because in the end, the cluster, the autoscaler of CastAI and also the rebalance mechanism are taking those configurations into account. I'm not sure if Skander wants to add something.
Yeah, that's exactly the answer. I mean, we help you guys before you move to spot. We give you the best practice. We help you to implement those best practices. Topology spread constraint, PDP, not anti-affinity. We make sure that your application that is spot friendly, when we deploy it on spots, will mitigate this downtime of interruption, because it's part of the life cycle of spot. But we need to deploy the best practice before moving to spot. And if the workload is not spot friendly, we can deploy it on demand. So it's not full spot or no spot. It's up to you to decide which workload can go to spot, which one cannot. You can do partial spot.
Awesome.
Good.
And we've got one more question. I know we've got more slides to get through. There's a lot of interest here, which is great.
Yeah.
More question, then we'll move on. The follow-up question we got is, do we take care of security and auto remediation? And if so, what kind of auto remediation can be handled?
I think this is a very large question. So we are not covering security because CastAI provide also a Kubernetes security posture management for vulnerability detection, for attack path, for runtime analysis. Yeah, we have the security product offering. That's part of our platform offering, and we help customer do an automatic remediation of their workload vulnerability. Yeah.
Awesome.
Maybe
Thank
we need
you.
another,
Yeah.
we need another webinar to explain this.
Yeah, whole other
Good.
webinar behind
Yeah.
that. But feel free to go to the website, cast.ai, and you can see the solutions and get the information
Yeah.
on security. Parimal, I know you've got a question. We'll come to that in a second. I want to make sure that we're able to hit on workload right sizing in the
Good.
next.
Nice. Exactly. So let's now make kind of reminder of the pain point of Mercedes. So there is a node optimization challenge, complexity of instance selection being packing, but also there is another problem of workload. So we are dealing with hundreds of dev team pushing new workload every day. So sometimes they are not right sizing, sometimes they are over provisioning. So Bertram, I want that you take the time to explain the benefits of workload autoscaler offered by Cast.ai.
Yeah. So I again take the opportunity to compare the workload right sizing or like also the component with one which is probably well known in the community. There's all of you probably know the vertical pod autoscaler, which in a sense got the same idea. So in runtime, defining a baseline on the usage of your workload for memory and also for the CPU. And then based on this baseline, you can fine grain how many how much requests should be set on the workload itself, and done this and apply those automatically in runtime. So this is basically what the workload autoscaler gives you as a capability. So based on on the baseline, which is calculated there, add an overhead of CPU load or memory, and then this is like the new request which is set, which is injected into your pod as a webhook on Kubernetes side. And also those new values are getting considered when it comes to auto-scaling decisions and also into the rebalancing procedure. So it's basically not or like there's no need anymore to set requests by hand, which is like super important in such a dynamic node scaling environment, because in the end the node scaling depends on proper sized workload, and the workload autoscaler takes care of the size of the part right sizing the workload, taking care that your request settings are properly made. And for example, in our environment and in some product teams, it's like really hard to determine what's the actual need of the workload, and this helps teams a lot to answer those questions, and then also to scale reliable, because in the end, if you scale too low, if you scale your workload too low, your cluster could end up with like too less resources, and then your workload is starving and it's not running smoothly, let's say. I'm not sure if
that's the good explanation. So I'm just trying to summarize. It's an admission book. It's very important. We don't create any conflict with your manifest. We don't touch this single source of truth. We don't patch deployment.yaml. We intercept the request at pod level. We do it via CRD, custom resource definition, and the recommendation comes from our backend. So it's like a dynamically in real time observing the increase and the decrease of your real consumption, and right size pods based on that. And this is what you see in this slide is like an increase in CPU and memory, because we can see that there is a bottleneck issue, there's a performance issue. So Cast.ai helped Mercedes-Benz team to solve the problem of performance, but also you can see in scaling down, where we can help you improve the efficiency of your application and eliminate the wasted resource at pod level. And don't forget, there is beam packing and rebalance. So all of the capabilities works together. It's like there is a combination between node optimization and workload optimization at the same time. Any other question about the workload autoscaler piece?
Not directly in Whoop, but there is a question about how Cast and Kube Scheduler integrate.
Yeah, that's a good question, by the way. So Bertram, can you explain how the autoscaler works with the native Kubernetes scheduler and the benefits of the pod pinner? How we can intercept some decision from this scheduler? Can you explain this part?
Yeah, with a pod pinner, you might need to help me out. But in general, maybe explaining one use case, you already were describing the behavior of the victor, for example. So what it does is it's identifying nodes where the workload can be evicted, and then the workload would be shifted to other nodes, right? And how would that make sense? How would that work with a scheduler? There's still the kube scheduler taking scheduling decisions. Like, I mean, it's the core component of Kubernetes. So when the evictor identifies a node which might be can be evicted with workload, it would cordon that node. The workload is evicted gracefully, and through the cordoned node, the scheduler just puts the workload on some other node. So bin packing that way with like, not additional configuration to the kube scheduler or anything. Also, on the other hand, when it comes to the scaling of the node, like let's imagine your cluster needs more resources, then it's also similar to how the cluster autoscaler works. A new pod is coming up. It's in pending state. You have from your scheduler, you get the notification that I lack resources, or also other like constraints, as we are talking about affinity rules or topology spread. And then the auto-scaling capabilities of CastAI takes care that a new node is coming up, and then the scheduler is scheduling on the node where it can accommodate the workload. But at least, and this is probably the pod pinner part Skander can explain, but like
that's a good question.
Those out of the box components doesn't interfere with the kube scheduler itself, I would say.
Yes, just to answer your question, which is a good question. We don't get any conflict with a native scheduler. We work together, but sometimes we offer something called pod pinner. It's another component that will intercept the decision made by the scheduler and make sure that the pod placement best scenario is respected, kind of. So it's another layer of intelligence to make sure that for example, the rebalance plan, this one, for example, you see here, sorry. For example, we want to make sure that from 10 to 6 instance, the pod pinner will make sure that the decision made by cast is guaranteed. So, and there is no other fragmentation created by other workloads. So we work together, and we can also help you improve the placement capability by the pod pinner, which is a really powerful feature. There is another good question also in the chat, and I will take this one. Nagaj is asking, does CastAI make sense if my workloads are 1-to-1, node to pod ratio? So 32 CPU hosts one pod, and this pod is assigned at 31 vCPU. Yeah, it makes sense. We will respect that. We'll give you the capacity you need. But think about it. Maybe you don't need 31 CPU. That's also the beauty of that. Maybe you are over provisioning your application. So we'll give you the request you are looking for, but we will help you to maybe right size this request. But if you have a rule of 1-to-1, you can feed this into the CastAI scaler, and we'll respect that. Generally, VPA does not work well together along with HPA. Does workload rightsizing work in this scenario? That's a good question. So we have our own in-house custom integration of HPA and VPA. We can scale both, but not at the same time. So we have different strategy. We know when we need to scale vertically, and we know when we need to scale horizontally. So there is a custom smart integration between HPA and VPA, and both of them can work in sync together.
Awesome. Thanks, Skander. There was also a question I answered just in a response on whether or not we support on-prem. Yes, we support all the major cloud providers, all the smaller cloud providers, as well as on-prem.
Good. So let me go to this because we don't have enough time. I want to give you more time to ask other question. This is the effect. This is Bertram trying to see the impact of disabling cast, which is very interesting slide, by the way. So you see how CastCI was enabled before 7th of November. We moved to full spot, then we disabled cast. And we want to do the same manually. So here it shows that it's almost impossible to do what CastCI is doing manually. Bertram, can you say something about this slide?
Yeah, so maybe one circling back, if you remember the challenging slide, we didn't like mention Spot at all because we just simply didn't had it in scope when, like, let's say improving the general scaling behavior of our cluster. But what this platform is offering is like really easy implementation of like using Spot instances, because in the end Spot instances are just another instance, or like or like it's just another like feature toggle, so to say, if you wanna use a Spot on your node template definition or not. And even if and what also from a platform side is really interesting, it's again up to the teams to make use of that or not. So you can easily like give your teams, your product teams, the possibilities of using Spot instances by them being in full control of the workload by, for example, setting tolerations and node selector configurations for Spot. And that was like let's say the quick win for us, especially then when it comes to costs. But yeah, along the way, it's like really easy. Was really easy for us to enable teams using Spot and save money that way along the way. Not sure if.
Yeah, this is good. So just to show you the complexity of managing Spot at scale, that you may have your in-house fallback mechanisms, that you may maybe put the right label. You have a stateless workload, but don't forget, we are here managing 120 clusters across different regions. So you need a centralized, smart, intelligent way to handle the scale of 120 clusters, and making sure that every scaling decision is cost efficient. Not only workload, but also move to Spot, and then beam packing, and then rightsizing. So it's a holistic optimization philosophy. I think this is the last slide, and we give you 50 minutes to ask other questions. We still have some challenge to solve with Mercedes-Benz team, and maybe Bertram can tell you more about that.
Yeah. So I think a couple of challenges here we talked about already, which we are still having. One of the biggest ones in our landscape, we're making heavily use of Java workloads, like those nice JVM, the cookie monster here to show the hunger for CPU in the beginning. So like the startup time of the JVM and the CPU consumption is like really like a big challenge for us to handle that, because there in the end you see how Java is not really well made for running on Kubernetes, let's say, and also in a especially dynamic environment when it comes to scaling. So what's the main issue here is the big discrepancy between like CPU consumption at startup and CPU consumption in runtime. So we have sometimes like the factor 100 where like between the consumption startup and between and runtime, and this is like really a huge challenge. For example, also making use of the workload autoscaler, because in the end you need to always to assure like a big amount of overhead, because it's a little bit philosophical question: what is the right size of a Java workload? Because in the end it needs resources in the beginning, but in the end it also doesn't need them. So it's really to find a proper balance here. We are looking forward to the new Kubernetes version. We are currently running an 131, and in 133 in-place pod resize is possible. So resizing workload during runtime without having the pod to be restarted might be a game changer, or at least like a big improvement for us here when it comes to those workload. And then basically the other two big challenges, and it's more like maybe a more an organizational challenge, because we as a platform can only give out best practices. We can't, or like we can of course enforce some of the stuff, and we do, like when it comes to security best practices or bottom baselines, let's say. But in the end we wanted to give like a lot of freedom to our product teams. And then if we introduce a new feature like dynamic scaling in our clusters, or like the workload autoscaler, we need to rely on the product team to make use of those features, also to be, I don't know, more cost aware, more resilient in what they are doing with their workload. And this is a big challenge. And then also enforcing those kind of resiliency best practices named on the slides are 3, like really making sure the resource requests are properly set by the application team. Pod disruption budgets are configured because of high availability reasons, and also the topology spread constraints to spread the workload across availability zones in the topology of AWS, and also to spread in the end the workload for making better scaling and scheduling decisions. Those are actually.
Thank you. Yeah, just I'd like to mention something about how we handle Java workloads. This is built in our system. We have something called ignore startup period. So we made our workload autoscaler smarter when it comes to rightsizing Java, and we can ignore those surge in the traffic during the first 20, 30 seconds. So we'll not right size based on this increase in the traffic. We'll ignore that. This is one of the mechanisms, and there's something coming in the 1.53, as you know, the in-place right sizing. Kastia was the first product to support this. We are supporting this for Azure. It's coming for Google Cloud and AWS next month, and our workload autoscaler will be able to right size your workload without any restart, what you call in-place right sizing, which is a huge improvement in the way we can handle workload right sizing. Yeah. Any other question? Can Kastia work alongside Carpenter? It's a good question. This is, I mean, we cannot scale nodes with Kastia and Carpenter at the same time. Carpenter can be used as a fallback mechanism. Some customers are doing that, but Carpenter has no capability to right-size workload. So the workload autoscaler part can be on top of Carpenter, but not our node autoscaler. And we proved that we are better in terms of cost saving. 50%, we can save 50% on top of Carpenter. So we have customer connecting costs on an optimal Carpenter managed cluster, and we can still save them money. Because again, Carpenter is not smart enough to do this intelligent beam packing. It can help maybe to reduce 10%, 15%, but you can see with Kastia, you can see higher cost saving. But yeah, just to answer your question, the workload autoscaler can be used on top of Carpenter, but not our autoscaler. So you have to migrate your workload from Carpenter to Kastia to manage them with the Kastia nodes autoscaler. But if you want to keep use Carpenter, you can use the workload autoscaler piece.
Awesome. There's also a question about if we're going to publish the webinar. Absolutely. We'll send out an email afterwards with the full recording.
Yeah, this is a good question about Carpenter. So I think for me, the best way to see how we are better than Carpenter is by just connecting Kastia in read-only and see how we can generate more saving on top of Carpenter. So it's not a promise. It's a reality. We have a lot of case. Can you please, Joe, drop the link to our case study? So we have almost 2,100 users, and a lot of them came from Carpenter. They've seen the benefits of CastAI, and they migrated from Carpenter to CastAI.
Yeah, we can share a couple examples of that in the follow-up with everyone.
Good, thank you. Feel free to ask questions, guys. We still have time for you.
There's another one that just got added, Skander.
Yes, assuming a cluster doesn't need bean packing and using custom compute class, how CastAI can benefit? So okay, let's take a scenario where we cannot move workload between nodes. So we cannot do bean packing. So we can help, for example, like GK Autopilot. We are not managing the infrastructure, but we can help you improve efficiency of your application. And you have something coming very soon called live container live migration. You will be able to move your pods between nodes seamlessly without restart, which is now an experimental stage. So it depends on which kind of workload that cannot tolerate bean packing. We can still bring some benefits at the application level. Bertram, I think you can take the second one. You mentioned that you have around 120 Kubernetes cluster at Mercedes. Is CastAI more efficient with one large cluster or many small ones? That's a good one. I like it.
Yeah, I mean, maybe really the comparison in the question you can probably better answer. Just, I mean, as a comment, we didn't choose our setup based on how we can scale our clusters in the most optimized way. So there are other reasons for like having like a lot of like small clusters per teams, which are more like organizational or like organizational related. And in the end, I would say it doesn't matter too much if you have like one big cluster or a couple of small ones, because in the end it's like the scale what matters. I mean, if you have like 100 clusters with like, I don't know, 10, 20 nodes, or one cluster with 1,000 or 2,000, in the end the node count is kind of the same. Running the workload, and if you can optimize those, I would say it doesn't really matter when it comes. I mean, what's the important metric here, I would say, is more like the CPU and memory resource, or like the consumption in general, and not the amount of nodes of your cluster. If that makes sense. I mean, we can also probably point to argue about, but this is at least how I would feel about it. But maybe there are also more numbers of, for example, Skander can mention if
yeah, that's a good question, by the way. Yeah, just bear in mind that we follow the same logic for 50 CPU cluster or 5,000 CPU cluster. So we follow the same logic. But think about cutting cost of 20% on a 5 nodes cluster versus 500 node cluster. So it's the same logic, but it's not the same, let's say, cut cost. It's not the same dollar you are burning. So CastAI becomes extremely efficient from 50 CPU. So when you have a cluster higher than 50 CPU, the bean packing algorithm, the rebalance, the spot can bring a huge benefit. So if you are trying to test cost on 60, 20, 3 nodes, for sure you will not see the huge delta in saving. So the bigger the cluster, the bigger the delta of cost saving. I hope that I answered the question, and feel free to post a comment, please. Okay, this is a good question also from Prudvi. Can you explain the scenario on dynamic scaling, HPA and VPA, instead of changing requests and resource manually in manifest? Yeah, as Bertram was explaining, we don't touch the manifest. We intercept the request or the number of replica by our admission notebook. So think about it, guys, like shifting right, not shifting left. We take the right sizing decision at the end of the CI/CD workflow. So we intercept. And the integration between VPA and HPA works in a way that we can scale vertically, and also we can scale horizontally, but not at the same time. So sometimes for some workload, we take a VPA decision, but for other, we take an HPA decision. So it depends on which kind of workload is deployed. It depends on your setup, if you want to do that or no. So we have customer, for example, Mercedes-Benz, they use VPA only on some workloads, but also they use HPA only on some workloads. It depends. We still have 7 minutes.
Another question here. Are you working on a feature that allows cross-cloud provider pod rebalancing? Assume GCP offers cheap GPUs and AWS cheap CPUs. I want to run my workloads on GCP and normal CPU workloads on AWS.
Wow, this is my best question, because you are building a product for that. We are building something called Omni or MNI. So when there is a scarcity of GPU in one region, we can help you to offload your workload to another region with available GPU. Yeah, that's something we are building. There is a dedicated engineering team working on that, but there is a huge demand from the Kubernetes industry to do this kind of cross-cloud GPU provisioning or optimization. Yeah, but it's something in our roadmap.
Stay tuned. It is not in our long roadmap. It is in our short roadmap. So you'll be seeing news on that shortly.
Yeah. Because I mentioned nothing about GPU, but we follow the same logic of CPU. GPU is maybe 6-7 times more expensive, but we apply the same logic. The beam packing, the rebalance, the right sizing. We can also help you optimize your GPUs, or your anything running on AI, machine learning also is a good candidate for Castilla.
All right. I know we're coming up on time. We've gotten a ton of questions today. Any other questions that folks have? All right. Well, big thank you to everybody for joining today's call. Big thanks to Bertram for taking the time, especially late in the day, his time, to join the call. We'll be sharing out a recording of the webinar for folks who weren't able to join earlier. And if you have any questions or you need any resources, go to cast.ai. You'll find, yes. Skander, great question. Is a free trial available?
Yeah, it depends. So you can connect your cluster in read-only in monitoring tool. Just go to console.cast.ai and click on connect cluster. Then the automation part is not free, but we can offer you the POC for free.
Yeah, so all of the analysis and recommendations are for free, and then you are free to play around and see the other features within the platform. Prudvi, thank you for the positive feedback. Glad you enjoyed the session. Really appreciate everybody joining. Stay tuned. We've got a lot more webinars coming up with great companies like Mercedes-Benz, sharing some of their best practices and how they're overcoming challenges that everybody's experiencing. So excited to see you all at the next webinar and in all the big events coming up the rest of the year with KubeCon, Microsoft, and reInvent. Thanks, everyone.
Thank you.
Thank you. Bye. Thank you.